Easy Physics and Mathematics. Today we are going to look at the model answer to IGCSE Physics Paper 2, and then we're looking at Variant 3, May-June 2024. Alright, so the total duration for this paper is 45 minutes, and then we are expected to use the constant acceleration due to gravity as 9.8 meters per second square. And then I want you to subscribe, like, and share. And then also, if you want to book for personal coaching, you can use this form, and I'm going to also place it at the subscription in the description to this video for students to subscribe if you want me to be your personal tutor and prepare you for the next exam, IGCSE Physics. Alright, so let's jump in and look at this question quickly. Alright, question 1. A student measured the volume of a small irregular shaped stone. Which apparatus must be used? So this is a giveaway question. The apparatus is B. So you use just a measuring cylinder. So let's see, you have a measuring cylinder. Okay, so let me just do that. Then initially you put water to a particular level, so call that V1. Then you submerge the stone. Then the volume will rise to V2. Then the volume of stone is equal to V2 minus V1. So that gives you the volume of the stone. Okay, which quantity is a vector? Question 2. We have electric field strength, energy, mass, and temperature. Energy is scalar, scalar, scalar. So the only vector quantity is A. Now, what are the other vector quantity? You can talk about velocity, displacement, acceleration, force, weight, momentum. All these are vector quantity. So these are vector quantity. When we talk about vector quantity, we are talking about quantity that has magnitude and direction. Okay, so let's go to question 3. Question 3. An athlete runs 2.4 kilometers in 12 minutes. What is the average speed of the athlete? So if you look at this question, your answer is given in meter per second, meter per second, meter per second, meter per second. So you need to convert. So speed is equal to distance divided by time. So if you do this to help you, distance, speed, and time. So sorry, okay, I use S here, which is the same thing as you can also call it V. Okay, so if the distance is 2.4 kilometers divided by 12 minutes, convert both of them to SI unit. This is 2,400 meters, and then this one is 12 times 60 seconds, because 60 seconds make 1 minute. So if you divide that, we give you 3.3 seconds. So let's move on. All right, question 4. The graph shows the speed of a car during a period of 50 seconds. So if you look at this from here to here, 50 seconds, and then the velocity, which is the vertical part. Now, for you to get there, the slope of VT graph is acceleration. So we can know when the particle is accelerating, this first part here. So what is the acceleration? That is delta V over T. So this acceleration here, A, is equal to 20 over 15. Okay, 20 over 15, that will give 1.5 meter per second square. Then here is deceleration, decrease in velocity as time increases. So you see that from 30 seconds to 35 seconds, as the time was increasing, the speed decreased from 20 to 15. So here you can now look at the deceleration, which is 15, take away 20 over 5. So you have negative 1 meter per second square. Then here again another deceleration. So is the speed decreased from 15 to 0. So we have 0 take away 15 in 5 seconds. That is from 45 to 50. That will give you negative 3 meter per second square. So greatest acceleration and greatest deceleration. So greatest acceleration, so the answer to here, we have greatest acceleration is B. Sorry, what am I saying? Number 4. Greatest acceleration is 1.3, and then the deceleration is 3. So the answer is D, not this. Okay. Question 5. Which statement about gravitational field strength is correct? Number 5, gravitational field strength. So the correct one is D, is equal to free fall. So gravitational field strength, so weight is equal to mass times a gravitational field. So gravitational field strength is the weight per unit mass. So this is wrong. Now this is wrong. This is wrong. Okay, it is the other way around. It's weight per unit mass, not mass per unit force. Okay, so question 6. Which property of an object cannot be altered by applying forces? So I think that is mass. Shape, spring, you can compress and enlarge a spring. Then speed, if you apply force in the positive direction to a particle, the speed will increase. Volume, if you apply force on an elastic material, it will deform. The volume can reduce, or you can enlarge it, the volume can increase. So yeah, so this A is the correct answer. So this can be altered by force, this can be altered by force, this can be altered by force. Okay, so let's go to the next question. Question 7. Question 7. A small ball of mass 0.1 traveling horizontally, that is, you have a small ball traveling horizontally with the speed, so this is 0.1, so let's call that PA. So this is A. Then traveling horizontally with the speed is 600 meter per second, and then it strike a wooden block, that is B, of mass 1.9 kg, and then it strike a stationary wooden block of mass resting on a frictionless surface. The ball stakes on B, so they stick together, so they are going to move together. And then for us to get that, what is the speed of the ball and the block immediately after the impact? So we are talking about momentum. So in this case, we have, this is an inelastic collision, so you have MA, UA is the only one moving, plus MB, UB equals to MA plus MB, and then they move with a common velocity. So if we want to do that, we know that MA, that is what, 0.1 times 600 plus 0, because this is 0, it wasn't moving, this block was not moving. Then finally both of them combine together, so you have 0.1 plus 1.9, so that is 2V. So we can get that, so that will become 60 divided by 2 to give us V, which is 30 meter per second. 30 meter per second. So number 7 is A. Number 8, an object taken underwater will be damaged if the total pressure acting on it is greater than 2.1 megapascal. What is the maximum depth that the object can be taken underwater before it breaks, given the atmospheric pressure is 101,000 pascal? Density of water is this. So we are looking at the total pressure. So P total is equal to atmospheric pressure plus pressure under water. So total pressure is going to be 2.1 times 10 raised to the power 6 pascal. So it's equal to 101,000 pascal plus pressure underwater. So this pressure underwater is rho GH. Density times gravity times depth. So we have density, which is 1000 times 9.8 times H. So make it sort of formula, so you can subtract this from this. So you have 2.1 minus 0.101 times 10 raised to the power 6 equals to, so we multiply this, which is 9800 H. So if you divide this, H should give us 203.977, okay, 9796 meter. So approximately 204. That is B. So let's look at question 9. A piece of solid metal melt to become a liquid. How does the particle of metal, how do the particle of metal or their behavior alter? So what is the variation in that? So if you look at that, we said that what is going to happen to the particle, you know, the particle of metal are closely packed and they vibrate in one location. So when you heat it, it's going to melt. So if this one become liquid, so the particle will be a bit far apart and they are free to move. So based on that, what is the correct answer? So they move around. B, each other. Okay. Now question 10. Brownian motion of particle is observed. Which statement describe the movement of the particle? Okay. The particle all travel along curved path. No. So what happened in Brownian motion is that you have a liquid, maybe water, then you put some on top of the water, you put pollen grain, then you look at this in the microscope, then what is going to happen? You see the zigzag motion because the water particle bombards the water particle that move randomly. You can't see the water particle, but you can see the pollen grain. So as they collide with the pollen grain, you see the motion of the pollen grain. So just moving around randomly on the surface in the water. So what is going to happen? So the correct answer is the particle move randomly. D. So let's go to the next question. Question 11. A fixed mass of air in a cylinder is compressed by a piston so that the volume of the air decreases at constant temperature. Now, how do all the particles, air particles, now collide with the cylinder wall? So we are looking at question 11. So if you have air particle in a cylinder, okay, let's assume this is the initial volume and then you keep the, so if you increase the pressure, so this P1, V1. So if you reduce it by increasing the pressure, that is P2, and then the volume V2. So in this particular case, you say that the particles, so let's assume you have 6 particles here. They were far apart, but now the particles are closer. And so what is going to happen? So in number 11, so the particle will collide with the wall of the cylinder more often, and that will lead to increase in pressure. Okay, because pressure is equal to force per unit area. So the rate of collision will increase. All right, so let's look at number 12. The diagram shows a quantity of gas trapped in a cylinder. The piston is pushed in slowly and the gas is compressed. The temperature of the gas does not alter, where it's almost the same thing. Now, which graph shows the relationship between the pressure and the volume of the gas? So this is Boyle's law. Boyle's law states that what the pressure of a fixed mass of gas is inversely proportional to the volume. So at constant temperature. So the answer is B. All right, so I want you to know that I want you to subscribe, like and share this video, and then you can also book a session online if you want me to prepare you for the next IGCSE exam. You have opportunity to book online, so just click on the form which I'm going to add to the description to this video, so you can use that to book for your online session with me. All right, now the liquid level in a thermometer rises when the thermometer is placed in hot water. What causes this? It's expansion. So this is a direct question. C. 13 is C. So let's go to 14. Which statement describe what happened as ice at 0 melt and become water? So number 14, the energy is absorbed and the temperature remain constant. And that energy that is absorbed that will make it to change, the quantity of energy that is called the latent energy. So the latent energy is the quantity of energy required to convert a unit mass to water at its melting point. That is the latent heat of fusion. And then to convert liquid to gas, it's called latent heat of vaporization. So the answer there is A. Now let's look at question 15. Question 15. Which rule explain how increasing the surface area of a fixed volume of liquid, water, and blowing air over the surface speed up evaporation? So basically, this question is comparing and contrasting boiling point. You are comparing boiling versus, that is evaporation versus boiling. Okay, so if you look at it, what's going to happen? What happened? Increasing the surface area. So take note, increasing the surface area, and then blowing air over it, that is draft. So both of them will speed up the rate of evaporation. Okay, so the answer is D. Increasing the number of water molecules close to the surface, and then it remove water molecule from above the surface of the water. So this one remove water, and then this one increases the number. So that is the answer to this particular question. All right, so let's see the next one. We have question 16. The table shows the state of material P, Q, R, and S, and whether each contain free electron. So using the information in the table, which comparison of thermal conduction in the material is correct? So want to see which. So if you look at thermal conduction thermal conduction, because it uses free electrons, so anyone that contains free electron has higher thermal conduction. So, and then the solid, there is contact, so arrow will be the highest. Arrow will be the highest, and then with R being the highest, so we have then the next one is Q. And then finally liquid, we have higher conduction, then followed by, what is this one here? X, solid. Okay, so the answer here is C. It is better in R than in Q and P. So it's better in R than in Q and P. So you will come in this order. So Q, R, S, P. So the conduction is like this. Okay. Question 17. A seismic wave has a frequency of this and a speed of this. What is the wavelength of the wave? So when we talk about wavelength, wavelength is equal to speed divided by frequency. So that will give us 10 kilometer per second divided by 5. So which is equal to 2 kilometer. C. All right, question 18. A sound wave will diffract when going through a gap or passing the edge of a barrier. Which size of wavelength give the most diffraction in each case? Now, passing through a gap. So if you have this, pass through a gap. Now, what is the standing rule? So once we know the thickness, the aperture, so this is A, and then you know the wavelength of the incoming wave. So the wavelength, so this is lambda. So this is the incident wave. So once lambda is almost the same value as the aperture, then the wave is fully diffracted around this place. So then, so the wavelength is similar to the size of the gap, and then diffracting over an edge. So for example, you play music, if this is a wall, so music bending towards the edge of the building, so large wavelength will lead to this diffraction. So if you have this, so here is the large wavelength of the incident wave for it to diffract around an edge. So like this one, this is the building. Okay, so let's go to question 19. A boy is having his eye, a letter is printed on a card. So what is going to be the refraction? So this is what? Lateral inversion, B. Okay, lateral inversion. So the answer is B.